Hello everyone, my name is Ahmad Nanda Yuma from Mercubuana University in Informatics major. Here I will describe about one of the topic in architecture computer, which is the internal memory. So let's get the ball rolling. So before I explain about it, first we should know about what is internal memory first. Internal memory, also called main or primary memory, refers to memory that stores small amounts of data that can be accessed quickly while the computer is running. There are basically two kinds of internal memory, ROM and RAM, which is ROM is read-only memory and RAM is random access memory. ROM stands for read-only memory. It is non-volatile, which means it can retain data even without power. It is used mainly to start or boot up a computer. For RAM, which stands for random access memory, which temporarily stores data while the central processing unit or CPU is executing other tasks. This is the picture of ROM and this is the picture of RAM. So I will explain more deeply about several questions that exist in computer access computer architecture book that that have that ha that already given by my lecturer. So here is several questions and my answer. The first question is, what are the key properties of semiconductor memory? My answer is they exhibit two stable or semi-stable states, which can be used to represent binary 1 and 0. They are capable of being written into at least once to set the state. They are capable of being read to sense the state. The next question is, what are two interpretations of the term random access memory? The first is a memory in which individual words of memory are directly accessed through wired-in addressing logic. Semiconductor main memory in which it is possible both to read data from the memory and to write new data into the memory easily and rapidly. The next question is, what is the difference between DRAM and SRAM in terms of application? For SRAM is used for cache memory both on and off chip, and DRAM is used for main memory. Next is, what is the difference between DRAM and SRAM in terms of characteristics such as speed, size, and cost? So SRAMs generally have faster access times than DRAMs. DRAMs are less expensive and smaller than SRAMs. The next question is, explain why one type of RAM is considered to be analog and the other digital. A DRAM cell is essentially an analog device using a capacitor. The capacitor can store any charge value within a range. A threshold value determines whether the charge is interpreted as 0, as 1, or 0. A SRAM cell is a digital device in which binary values are stored using traditional flip-flop logic gate configurations. So here the next questions. What are some applications for ROM? My answer is microprogram control unit memory, library subroutines for frequently wanted functions, system programs, and function tables. Next is, what are the difference among EPROM and EEPROM and flash memory? EPROM is read and written electrically before a write operation. All the storage cells must be erased to the some initial state by exposure of the picture chip to ultraviolet radiation. Erasure is performed by shining an intense ultraviolet light through a window that is designed into the memory chip. The EEPROM is a read-mostly memory that can be written into at any time without erasing prior contents. Only the byte or bytes addressed are updated. For flash memory is intermediate between EEPROM and EEPROM in both cost and functionality. Like EEPROM, flash memory uses an electrical erasing technology. An entire flash memory can be erased in one or a few seconds, which is much faster or more faster than EEPROM. In addition, it is possible to erase just blocks of memory rather than an entire chip. However, flash memory doesn't provide byte-level erasure like EEPROM. Flash memory uses only one transistor per bit and so achieves the high density or compared with EEPROM of EEPROM. Explain the function of each pin in figure 5.4b. Here is the figure. So I will explain about the function of each pin. So for the first is A0 until A1 is address line, and CAS is column address select. D1 until D4 is it means data lines, and C it means no connect. OE it is output enable. RAS is row address select. VCC is full text source. VSS is ground, and WE is write enable. The next question is, what is a parity bit? A bit appended to an array of binary digit. The next is, what is a parity bit? A bit appended to an array of binary digits to make the sum of all the binary digits, including the parity bit, always odd or odd parity, or always even parity. So it cannot be compound like odd and even. Then how is the syndrome for the Hamming code interpreted? A syndrome is created by the XOR of the code in a word with a calculated version of that code. Each bit of the syndrome is 0 or 1 according to if there is or is not a match in that bit position for the two inputs. If the syndrome contains all 0s or no error has been detected. If the syndrome contains one and only one bit set to 1, then an error has occurred in one of the four check bits. No correction is needed. If the syndrome contains more than one bit set to 1, then the numerical value of the syndrome indicates the position of the data bit in error. This data bit is inverted for correction. The next is, how does SDRAM differ from ordinary DRAM? Unlike the traditional DRAM, which is asynchronous, the SDRAM exchanges data with the processor synchronized to an external clock signal and running at the full speed of the processor or memory bus without imposing wait states. The next is, what is DDR-RAM? DDR-RAM stands for Double Data Rate Synchronous Dynamic Random Access Memory. These are the computer memory that transfers the data twice as fast as regular chips like SDRAM chip because DDR memory can send and retrieve signals twice per clock cycle as a comparison. They are widely used in applications that are demanding high-speed memory, for example, graphic cards that need to access a large amount of information in a very short time to achieve the best graphics processing efficiency. The next is, what is the difference between NEND and NOR flash memory? NOR and NAND flash memory are different by their architecture and purpose. NOR memory is used for storing code and execution, allow quick random access to any location in memory array. So for the NAND memory is used for data storage. The next is probably the last is list and briefly define three newer non-volatile solid-state memory technologies. There are three newer non-volatile solid-state memory technologies, which is Intel Optane DC plus 10 memory, non-volatile high-capacity memory turned for data center workloads, and can be accessed through memory operation or as a block string. And MRAM is non-volatile memory that can be powered down completely and then awakened quickly for fast writes in an IoT application. And ReRAM is promised to bridge the gap between DRAM and flash in the data center. Storing entire database in fast, non-volatile RAM would revolutionize in memory computing. So that's all from my presentation about internal memory and several questions about it. So I hope you can get new knowledge from it. So that's all from me. See you later and thank you.